Hello and welcome back. Okay, so in this video, I wanted to talk to you about the AWS Systems Manager service and specifically the run command feature that comes with AWS Systems Manager. Now, the run command can actually help you remotely manage all of your compute devices on AWS. So that's your EC2 instances, edge devices, and even your on-premise virtual machines in your hybrid cloud environments. In this video, we're going to take a look at Systems Manager run command and also do a hands-on demonstration. Let's do this. Okay, so traditionally, when you're working with AWS and you're trying to manage your compute devices, such as your EC2 instances located inside of your VPC, you will need some form of remote access. Now, Alice here would traditionally have certain things provisioned for her to grant her that remote access. So in this case, she may go with bastion hosts. Bastion hosts are basically management servers that you deploy in a public subnet of your VPC that have been hardened and have been configured specifically for the purposes of remote administration. So in this scenario, once you've deployed the bastion host, you'd need to configure certain inbound rules by means of security groups. So if you want to manage Linux-based instances, then you might want to open inbound port 22 for SSH. Or if you want to manage your Windows-based instances, then you would want to use remote desktop clients, and therefore you would need to open port 3389 inbound for RDP, remote desktop protocol connectivity. So once you've got that in place, Alice can then go ahead and make those remote connections. She'll be connecting to the bastion host first, and then effectively jumping onto those EC2 instances in your private subnet in order to remotely administer them. This approach comes with a number of different drawbacks. For one thing, your bastion hosts are actually exposed out onto the internet. Sure, they may only be accepting traffics on port 22 and 3389 respectively as per the diagram, but nevertheless, there is the concern that there's a security risk factor here. Not to mention that you do have to manage your bastion hosts and take care of them. You have to update them, patch them, make sure that they're highly secure, all that stuff. An alternative approach is obviously you can configure VPN connections between your on-premise network and the VPC, and obviously connect to your EC2 instances in your VPC over that VPN tunnel. Here again, you have extensive management overhead because you have to establish and configure a VPN connectivity. You have to deploy customer gateways and configure the VPG, the virtual private gateway on the AWS side. Now, there is an alternative, so let's take a look at that next. For some organizations, there may even be a security team that decides not to allow direct access to production servers via SSH or the use of bastion host. And so it becomes a corporate policy that you as an engineer will have to take into account when you're building your architectures on AWS. So what is the alternative? Well, for a start, we definitely will need to get rid of the bastion host and those inbound security rules, and instead come up with a different solution to help us manage those EC2 instances. Now, AWS does provide that alternative solution, and it is the AWS Systems Manager service, which comes with a plethora of different features. One of them being the AWS System Manager run command. So how does it work? Well, with the AWS Systems Manager run command, you're able to remotely and securely manage the configuration of what are called managed nodes. Now, a managed node can be any EC2 instance, edge device, or even on-premise service that have been configured to work with Systems Manager. Okay, and the run command will allow you to automate common administrative tasks, perform one-time configuration changes, issue commands such as Linux shell commands, or even Windows PowerShell commands. So next, let's take a look at what you need to do in order to configure your EC2 instances to be able to work with AWS Systems Manager. Okay, so in order to configure your devices to become managed nodes for System Manager, there's a few things you need to do. You will need to install an agent on your EC2 instances called the SSM agent, and you'll also need to configure them with the necessary IAM roles so that Systems Manager is able to communicate with those EC2 instances. Okay. And in addition to that, obviously, you can establish connectivity with your on-premise environments if you want to manage your on-premise service. Obviously, for that, you would also need to effectively deploy your SSM agents to servers that you want to manage. Once you've deployed your SSM agent and configured your IAM roles, you're now ready to go. you will be able to now communicate with those EC2 instances or your on-premise servers using the run command. Now, when it comes to EC2 instances, there are some AMIs, Amazon Machine Images, that you can get directly from AWS that already are pre-configured with the SSM agent. So when you're thinking about corporate strategy in terms of rapid deployment of your new servers, perhaps you want to incorporate the SSM agent in any corporate AMIs that you have designed for your organization. So if you've built your own AMIs, okay, then you might wish to consider incorporating the SSM agent as part of that AMI as well, so that when you deploy new AMIs to your EC2 instances, they're ready with the SSM agent pre-installed. Okay, that's enough of all of the explanation and how this is all supposed to work. Let's actually jump on into the AWS Management Console and demonstrate how we can configure AWS Systems Manager run command. Okay, and here we are on my AWS Management Console. I'm currently in the London region. Now in the London region, I happen to have a VPC within which I'm going to deploy my EC2 instance that I'm going to manage using SSM Systems Manager run command. So you can choose to deploy your EC2 instance in any default VPC in the region of your choice, or perhaps you already have a VPC where you're currently deploying some EC2 instances. Now essentially what we need to do is first of all configure the prerequisites. So one of them being the fact that you need to set up an IAM role so that SSM Systems Manager and EC2 instances can talk to each other. Okay, so we're going to do that first. We're going to go into IAM, and I'm going to open that up in another tab. Okay, and then on the left hand side, you click on roles and then click create a new role. Now the trusted entity type you're going to select is an AWS service, and under common use cases, select EC2. Click next. And then under permissions, there already exists a managed policy that you can use to set this all up. Just type in Amazon SSM, press enter to do a filter. And the one that you want to go for is the Amazon SSM Managed Instance Core. So select that one, click next. We need to now give it the role name. So I'm just going to call this EC2 to SSM, something simple. I know what exactly that means. You might want to wish to elaborate on your role name there. And then go ahead and click create a role. Okay, so that is the role created for you to allow SSM and EC2 instances to talk to each other. Okay, next step, let's go ahead and deploy an EC2 instance. So we're going to go into EC2, and I'll open that up in another tab. And what we need to do next is basically launch an EC2 instance. So I'm going to go ahead and launch a Linux-based instance, and we'll give it a name. Okay, and the OS that I'm going to be using, the Amazon Machine image that I'm going to be using, is an Amazon Linux 2 image, specifically that kernel 5.1 for the purposes of this illustration. So we'll just keep that selected. We'll also go with T2 Micro. We want to keep costs within free tier for the lab. And when it comes to the key pair, so because we're not going to be using an SSH client, we don't need a key pair, right? So we're just going to go ahead and say proceed without a key pair. For the network settings, I've got a VPC. So I'm going to select my VPC that I've already established, and I'm going to place this particular server, this particular instance, in the app subnet 01, which incidentally is a private subnet. So in other words, the actual instance isn't going to get a public IP address. All the more just to try and illustrate how we can connect to servers in the private subnets of our VPC using Systems Manager. Okay, I'm going to leave everything else as it is. And under advanced details, okay, we're also going to make sure that we select that instance profile, that IAM role that we had set up earlier. So we'll select the IAM role. And then finally, we'll go ahead and click launch instance. So the instance is being launched with the IAM role attached to it that will allow SSM, Systems Manager, and EC2 instances, this particular EC2 instance, to talk to each other. So we can go ahead and view all instances, and we can see that it's just launching over there. I'll pause the video here, let this server come up fully up and running, and then we'll move on to the next step. Okay, so our server is now up and running. There it is in the running state. It's passed its status checks as well, so that's all good. The next thing we're going to do is we're going to jump on into the Systems Manager console and take the next step there. So if we just do a quick search for Systems Manager, there it is, and I'll open that up in another tab. Okay, and in Systems Manager, on the left-hand side under Node Management, you want to click on Fleet Manager. And in Fleet Manager, you will notice that the Linux instance we just deployed is already being showed as a managed node. And the reason for this is because the SSM agent is already installed in the AMI that was used to deploy this instance. And also the fact that the IAM role is attached to this server. Okay, so AWS Systems Manager is able to communicate with this server. Fantastic. So we can actually select this particular node. And this is the details page. So it tells us the node ID, what platform it's running, the node type, and you're able to see the parameters of this actual server. Okay, and so next you click under Node Actions and click on Execute Run Command. And this brings you to the Run a Command dialog box that you can use to basically execute commands on your EC2 instance. So on this Run Command page, there are several different types of commands that you can run. And in the search box, if you select document name prefix equals, and you want to go with AWS update SSM agent, okay, and that's the SSM agent that you are going to select over there. So we're going to click on that one over there. And then basically if you scroll down, you'll see the target selection. Now we've already selected the target, which is our EC2 instance against which we're running this command. So we're going to go ahead and basically click on run. Okay, and that's going to go ahead and execute the command to update the SSM agent on this machine. And you want to make sure that it's the latest agent that is running on your EC2 instances. And just done a quick refresh of the page there, and you will see that we've had a successful deployment and we have run our first remote command using Systems Manager. Next, I'd like to demonstrate how we can actually run a shell script on your EC2 instance using SSM run command. Now, there are actually multiple ways of issuing commands to your EC2 instances. You can either send commands individually to a specific EC2 instance using the run command, or you can actually run entire scripts that are pulled down from a repository such as Git or Amazon S3. Let's take a look at the first option. So basically, I've got two EC2 instances running in my AWS account. If I click on the one that we're interested in, the Linux 01, this is the details page of that server. I can go into Node Actions and click Execute Run Command. And then from there, select the option to run a particular shell script. So you can click on document name prefix is equal to AWS run shell. And if we just do a search on that, that should pick it up. There it is. So AWS run shell script, that's the one we want. You provide your command parameters in this box. So for instance, you would provide something like sudo yum update -y to update the operating system on your Linux instance. And then you would obviously go down and choose your instance. So we've already selected our instance, that's the Linux 01 instance. And it's a simple case of then selecting some optional parameters if you needed them. So the output options allows you to write all of the command output to an Amazon S3 bucket, which you can store as log information. You can also trigger CloudWatch alarms, and you can send SNS notifications to be notified for what's happening. Now, the alternative way, as I mentioned just a few moments ago, is to actually build out your script, store it in a repository such as Git or Amazon S3, and then use System Manager to run that script, pulling down that script file from the repository. So we're going to take a look at that next. So I'm just going to quickly cancel from here. And what we're going to do is we're going to take a look at that alternative option. So I've still got my two nodes running in Fleet Manager. But what we want to do is we want to use a script that we've built, okay, and essentially deploy that from the repository. Now, if these EC2 instances are going to be pulling down script files from a repository such as Amazon S3, well, here's the thing. They're actually going to need to be able to talk to Amazon S3. So in other words, they need an IAM role that gives them sufficient permissions to access Amazon S3. Now, if you remember earlier on in this session, we had created a role for AWS Systems Manager so that AWS Systems Manager and EC2 instances can talk to each other, right? So that Systems Manager is able to send out those commands to EC2 instances. An EC2 instance can only hold one role at a time, but that role can have multiple permissions. And so for that IAM role that we previously created, which granted EC2 instances the ability to work with Systems Manager, we need to update that role. We need to add another policy to also enable our EC2 instances to pull down files from Amazon S3. So we just click on the IAM console over there and we go down to roles. And in role, if you remember, we've got the EC2 to SSM role that we had created earlier in this session. And that's got the Amazon SSM Manage Instance Core policy applied to it. So we need to update this. We need to add another permission, attach policies. And this time we're going to attach an Amazon S3 policy. I'm just going to go with Amazon S3 full access for the purposes of this lab. And then I'm going to click attach policy. And that's done. So now that policy has been updated. Okay. That policy is now part of the role, which if we go back to our EC2 instance and have a look at the Linux 01 server under security, you will see that the role has been applied to the server, okay, because that's how we launched the server. So all of that is fantastic. The next thing that I want to do is actually show you this script. So we're going to open up Amazon S3. Now I've previously created the script and stored it in an S3 bucket. Okay, this sample script, if you are interested, is available to you in our GitHub repository, the link of which is down below or in the resources section of this video. But this is my bucket. I've called it Vegan Dev Shell, and in it I've got some files in there. Specifically, the script that I'm interested in is the web script.sh, and I'll open that up for you very quickly so you can see what it's all about. Okay, and there it is. So it is essentially a script that will update the operating system. It'll install the Apache Web Services, it'll install Ruby, and also it's going to install the AWS Code Deploy DevOps tool that comes with AWS, that AWS provides us. Okay, Code Deploy is a solution that enables you to deploy application to your EC2 instances using DevOps principles and methodologies, and that's obviously a discussion for another video. But let's just go back to our console, okay? And in our console, we've got the shell script in place, we've got the IAM policy in place, and so what we can do now is actually set up our Systems Manager to be able to use this script to be deployed on our EC2 instance. Okay, so let's just go back to AWS Systems Manager. Okay, we'll just actually close this one. Let's go into Fleet Manager, just try and clear the screen a little bit. So we've got our two EC2 instances. The one we're interested in is the Linux 1 instance. And so to run that shell script that's stored in Amazon S3, essentially what you need to do from the left-hand menu, if you scroll down to Run Command, click on Run Command, and search for document name prefix is equal to AWS run. If you press enter there, you want to use the AWS run remote script. Okay. And if you scroll down a little bit, your source type is going to be obviously Amazon S3. And then you need to supply a source info. Now the source info needs to be in a particular format. So for instance, it can be in a format like this. So path points to a particular URL that holds the script. So in this case, this is just a sample link over here that points to a bucket in the US West 2 region in a folder called script and a folder called shell, and the file name or the script name is helloworld.sh. That's not our script, obviously. If we go back to Amazon S3 very quickly, go into Vegan Dev Shell, the one that I'm interested in is the web script.sh. Okay, and that's the object URL. So I'm just going to copy that object URL and place it in those double quotes over there. Okay, so that's my path. My path is pointing to the Vegan Dev Shell bucket, which is in the London region, .amazon.aws, and it's a file or an object called webscript.sh. In the command, you need to actually call the actual script file, the sh file. So again, I'm just going to copy and paste that in there. That's what it's going to be running. Next, you want to select your instances that you want to deploy it to. So I'm going to select my Linux 01 instance. You can create a resource group and club together multiple EC2 instances in that group so that you can apply it across multiple EC2 instances in one shot. You can specify a comment, and the same thing, right? You can have some outputs sent to your S3 bucket for logging information, trigger CloudWatch alarms, set up SNS notifications, etc. We're not going to be doing that in this lab, but hopefully you get the idea, and then you click on run. Okay, so now the command or the script is being pulled down from Amazon S3 thanks to that IAM role that has the necessary permissions, and it's being executed on Linux 01 server. I'm just going to do a quick refresh, and there we are. We've got a success already. Okay, so that's gone through well. That has been successful. It has sent that script to that EC2 instance and run it. And we can actually test it out. So let's go into instances over here. The instance that we're interested in is that one. I'll connect to it using Session Manager. Now, Session Manager is another key feature of Systems Manager, and I'll basically create another video to show you how Session Manager works. But essentially, because of that IAM role, and because of the fact that we've got the SSM agent installed, we can use Session Manager to remotely connect to the interactive console of your EC2 instance. So I'm going to click connect. Just bring that over here. That's going to open up my Linux 01 server. Okay. And if we do sudo su, and what we can do is basically test whether, those commands have been run. So for instance, the command, if I bring it up again, is installing Apache Web Services, Ruby, and also deploying the code deploy tool on your EC2 instance. So we can test that out. We can actually navigate to cd var www html. Okay, and you can see that there is indeed an HTML directory, and that would only happen obviously if you're installing some web server. You can also run service httpd status, which will tell you that the Apache Web Services is actually running. Okay, so that basically proves that Apache was installed. And in fact, if you remember, we actually deployed the code deploy agent on our server, so we can check whether that's running as well. And you can see that the AWS code deploy agent is running as PID 5994. So my script ran, it was successful, and we're all good to go. Well, I hope you enjoyed this video, and if you did, please hit the like and subscribe button for more videos from the IAS Academy, and I'll see you guys soon. Thank you.